Oh, where are we here? There we go. All right, let's get underway. So, if you're seeing this recording, I guess you didn't drop the course after day one. Good. So here I am. I'm in Halifax. My wife is still in Kingsburg, but Dora is with me. She's coming to my class tomorrow morning. Uh, that'll be interesting. We'll see how things go. So this is Dora down on Kingsburg Beach. And so that's where we are, or my wife is in Kingsburg. And they've got a beach that it may fill up with seaweed, but it's most of the time doesn't have it, and most of the time nobody is on it. It's amazing to have such a nice big beach that's so quiet and peaceful. Anyway, let's get started. That I'm presume you have registered for Top Hat, and that's how you're seeing this video. That in terms of getting in touch with you, is email the best way of doing it? If you're using email in Banner, that you get to set your preferred email. And when you set yourself up in Banner, you are issued an email address, and they may have set your preferred email by default at the St. Mary's email address. If you use your Gmail or Outlook or other email account most of the time, you may want to go in and change that. So a few announcements, and this will be the case at the start of each day, as I'll run through a bunch of announcements. So if you don't watch the videos in future, but just see the PowerPoints, you will see reminders at the start of each set of slides for the course. And so quiz number 1 closes this coming Saturday at midnight. And the course outline quiz, it's a new feature to get you to read the course outline and make sure you understand it. It also closes at the same time. So you got 2 quizzes, 2 points each. Get them done. And there's a discussion posted. It's a simple one, asking you if you've really encountered firms that you think have been using data mining to go and influence your behavior. And if you have, tell me about it. Tell the others about it. Everyone can see your discussions. And it's interesting to see the different takes on it. There's actually other applications, I should mention, that you get all the time without maybe knowing it. If you use texting on your phone will prompt you with certain words that it thinks you're going to type in next. That's a form of data mining. They're trying to make a prediction of what word you're trying to type. So there's a lot of these things that we just take for granted, but they are happening behind the scenes. I should make mention that there's an awful lot of activities in the course, as I mentioned last day, and many students forget about some of them because there are too many, and they would appreciate notifications. I understand that if you install the Top Hat app, which you can get from the App Store, whether that's Apple or Google or what have you, you can set it up to send you notifications to your phone of things that are due. I don't know about it. I haven't used it, but I just got an email about it yesterday. So that I mentioned the discussion being due. It's not due this Wednesday of this week. It's due Wednesday of next week. And I would encourage you to participate. It's just a reflective exercise. There's no right, wrong answer. You only get points because you participated. So any participation will count. Even if you send in gibberish. Mind you, everyone knows what gibberish you posted. So there's a little bit of policing there. So the first one is about online ads, that type of thing. And you will see some interesting examples that people will post about what they've seen. But a lot of the online or the data mining that firms are doing about you, you don't know about. They are most successful with their data mining when they keep it secret, that they try not to make you recognize that they're mining your behavior. Just like in the Target department store case in the first class, they don't want to creep you out. They don't want you to try to shut down and not interact with them in some fashion. You've received an email from me about participating in a survey. And last time I checked, I had 60 or 70 students have participated. That's good, but there's over 400 in the course. Um, so that's out of the whole course that participated. So it's a very small percentage. We need to get about 300 students answering the survey. That I'll send you reminders. I'm going to nag you about this. You can't get away from me. The data is going to be used in assignments 1 and 2. I'm going to take your data and merge it with data from the last 3 years. And it's interesting. We've been able to track what's been happening with students over the first survey was done actually before we realized COVID was going to be an issue. It was done in January, and then in February we discovered it. And so it's been interesting to track all kinds of different aspects of the demographics, the mental health, the finances, all that type of thing. And I've been feeding that to the university administration about, hey, this is what's happening among our students, because they really don't know. So from last year's class, some of the things that came out, I asked them, what's their biggest fear? Have you ever been asked that before? That most of them were worried about their grades. Far and away, that was the biggest thing. The other was about not making friends. And that's varied during COVID. Obviously, during the 2020-2021 year, when we were all online, so they had a lot of trouble with that. Online classes have bothered them. We had quite a few last year, much less this year. But online is worrisome to them. You're in an online class, so I'm presuming you think this is a good idea, but may or may not be. It's mixed results. Last fall, my online class was probably my best class. COVID has been ruining life on campus. That's what they felt last year. And it really changed things. I think this year we're closer to being back to face-to-face, although COVID actually is worse than it's ever been. The other area is workload, their time management, and falling behind. And that, I'm going to try to manage your workload reasonably well in this course. Time management is a huge issue in this course because you have to manage your time to be successful, and you can't fall behind. Can't let you. Some of the things that they said, and comparing them over the 3 years, because this is interesting. Last year, a lot more were working or looking for work, even more so than before COVID. I think that finances are the cause of that. That grades, last year, they felt really bad about their grades. They were much less than they were expected, much lower than they'd seen before. You'll notice the blue year is the COVID year, the online year, and they earned grades that were much, much better than they expected. Worrying about grades, that seems to be a constant. It's big, really is big. Few said that they had success making friends last year. Of course, it was very low during COVID. I'll be interested to see if this year we get back up to 37%. Depression, it was better than during the lockdown year, the fully online year, but look how high it is. It's still quite frequent. This is a big deal, and I don't think people understand it. And this was a big deal before COVID, and we didn't know it. But I still don't think universities understand this. There are a lot of similarities among the students, but there's a lot of big differences. You're very different from each other. You're not all the same. Yet we tend to teach you and interact with you like you're all the same, like you're all average. You're not. There's no such thing as a typical student. And that has been, I think, the most powerful outcome of doing these surveys is to see how diverse you are. So that's again why I asked you respond to the survey, because you're different from everybody else. Everybody is different. Sorry, this is a slide from my in-person class. I'd like to actually get to know you. I have trouble even with a large, I've got 70 some in the in-person class, and it's hard to get to know them. It's much, much harder to get to know online students. And this is important. If you're doing a lot of your courses online, you'll need reference letters. When I'm finished this, I'm writing reference letters for a student I taught 5 years ago. I vaguely remember her, not really well, but she needs references for a program she's getting into. And that's really common. Faculty are asked to write references all the time. And she's asking me to write it. I'm a first year, I taught her in first year. Why isn't she asking her second, third, and fourth year professors? She didn't get to know them. Get to know your profs some way, even if it's by email. And some of them in the last few years, I've gotten to know by email, but I've never met them face to face. Find a way to do that. Interact with your professors. Whoops. More announcements for you. Time management's a big deal. It's the main reason students mess up in this course and probably in all their courses. That it is difficult to manage your time, and it isn't just as being a student. I have trouble managing my time. That so there's a workshop being offered. This is for new students, but there are other ones for returning students. Well, you're a new student. I would encourage you to take part in these things. These are posted regularly. There's a Societies and Partners Expo. Get involved. I can't emphasize enough to you how important it is that. So there's another one in terms of the volunteer fair. Same deal. It's involvement. That in surveys nationally, and St. Mary's, at least in my time as an administrator, would participate in this. The question among first-year students about what was the best thing about their first year, the number one item that comes up, it's a free-form question that's posted, but when you see the results, it overwhelmingly says making friends was the best thing that happened. And you can probably even ask graduates, what was the best thing? It was making friends. It is the thing you will remember most when you graduate. You will not remember me, this course, or any of your other courses probably, but you will remember making friends. But unfortunately, the worst aspect of their first year is also not making friends. That doesn't happen automatically. You have to interact with people, and you're online. So you're even more divorced than the ones in person. These are from surveys of in-person students. You've got to get involved, get outside your comfort zone, volunteer. Volunteering is also important for your resume. That employers, they get hundreds of resumes. You're a lucky group because we now have an employee shortage. We have more jobs than we have people applying. But still, it's competitive for really good jobs. And one of the things that employers used to tell me when I was a dean, like, what could we do in our program to make students better for them? And they said it was nothing to do with what we taught in a classroom. It was really strange. I wanted to know, did we need more marketing in our program, less accounting, less math, whatever? They said, doesn't matter. What they're interested in is the person that they're hiring, not the training necessarily. And it's the values of the employee. I said, well, how do you evaluate values? I said volunteering. You're doing something without getting paid. You're doing it because you think it's a good thing to do and you enjoy doing it. And that speaks volumes about what type of character you are. Volunteering is critically important to getting a really good job. That get engaged. And you may start with a student society. That Enactus is one where many students have found it's brought them out, but there are others as well. And getting involved outside the university is really important. Volunteer fair is a way to find a way to do that. If you don't like it, fine, you can drop out. Try something else though. But do volunteer. But get out of your comfort zone. Okay, so day one, it was really about defining what the course is. And it's about describing a process. It's not simple. That's why we need a course. It's identifying things that are valid, that are true, and we're going to evaluate them to make sure that the predictions we make are true, or most of the time they are. We're trying to discover something new. We're trying to do it in a useful context, and I'll try to give you problems that where it's practical. I'm not just giving you an end of chapter exercise that someone just made up. These are real situations. We want ultimately understandable patterns. Ideally, that's what we'd like. And we're going to be focusing on that, especially when we do value estimation. And that students actually find difficult is understanding the pattern and explaining the pattern to somebody else. And it's going to come from a structured database. I'll give you the data. So today, I want to go through a number of the most common data mining applications, and I'm going to describe the process that's very commonly used, and we're going to use it as the basis of the sequence of classes through the term. Okay. So first off, what's problem solving? Everyone says we need to develop better problem solving skills, but they really don't define what they mean by it. Employers say this all the time, and many profs say, oh yeah, my course, we teach problem solving. Anyone that teaches math says that they do that. They don't. They teach you how to solve really structured problems, but the ones you encounter in practice aren't. When you're solving a problem or performing a task for the first time, where do you start? If you're in the classroom, we do this and students post on a screen through Top Hat, the different ways they think of starting problems. So unfortunately, you can't do this. This isn't an interactive video. First task generally is to define what it is. Make sure you really understand what it is you're supposed to do, what you're supposed to solve. So if you're told go and do something, say it back to that person in your own words to make sure what you think you heard them say is what they thought they said to you. And there's often really big communication gaps there. Unfortunately, a lot of managers don't know what they're asking for. They don't know what they need. So you're going to need to do back and forth, and we'll talk about this, a lot more than that. We really need a process for doing this. You might start out by, if you know what the problem is, by asking yourself if you've ever seen it before. Have you seen something like that? That experience there becomes really valuable. That if you're an old guy like me, I've seen certain types of problems a lot. So I have a good idea where to start. There are lots of problems that I've never seen before. I don't know where to start. My first thing would probably be to go and find an expert and ask them. Sometimes that isn't available to you. So where do you start when you're left on your own? Where does a novice begin problem solving? So we're going to look at a framework and process for problem solving. But we're going to start out with that question, have I ever seen this problem before? And we're going to be looking at problems specifically that need data to be able to solve. If you did Management Science 1205 in the fall, you did a bunch of linear programming problems. and you went through a whole bunch of different applications. I don't know if it was hammered home. Why were you doing those different ones? It's because those different ones are fairly classic ones. And you might go and ask yourself, sounds like a product mix question, or this looks like an investment problem, or this looks like a production inventory problem, or a transportation, a scheduling problem, those types of things. You may recognize certain classic problems. The problem you've got in front of you looks sort of like it, but it has some differences. But recognizing one that looks very similar to yours in some respects might give you an idea of where to start. And that's why it's important to have an idea of some of the common data mining applications. It's valuable even if you're not the problem solver. Depends upon what your role is. That it may be that you're in a managerial role or some type of support role, and you want to figure out what's the data analyst going to do for you? What's their role? And what should you expect out of them? So understanding applications that they should be able to solve is important to be able to hold them to account for what they did or didn't do for you. As a data analyst, and we're going to sort of play that role, you're going to go and sort of start out, do I recognize this? No. Does this look similar to something I've seen before? Is there a best practice for these types of problems? Is there a standard way that we normally approach it? Are there certain problems, certain pitfalls we commonly encounter? Because we want to want to know about the bad things before we get started. And you need to know about those. So a lot of them involve making predictions. And that's much of the focus of this class is going to be on applications that involve predictions. That you're advising a customer about what cell phone plan. So you would want to know, well, how many gigabytes of data are they going to use? So you don't sell them too much and they get turned off by the high price that's going to be charged. You don't recommend too little because then they're going to complain that they got the wrong plan. Maybe you're trying to guess with a current customer, are they likely to switch service providers? Given your history of what you've seen with that customer, are they likely to switch? Is there a way to change their mind before they switch? Keeping a customer is usually much cheaper than finding a new one. But there's also a lot of descriptive models. And I guess my history in doing advising using data, it's been much more descriptive. I've tried to make some predictions. We may talk about them later. But a lot of it was informing people so they know the context in which they're making a decision. We might do things like profiling. What's typical behavior of a particular credit card customer? And so if we're seeing something that we think is not typical of them, then maybe that's an indication that their credit card's been stolen. So we need to understand the descriptive thing. What do they look like? That's descriptive model. Trying to get an idea of maybe if fraud is present. We're often searching for patterns, and our objective is to influence behavior. So some of it may be a descriptive model, but you're trying to change behavior. So Amazon, they'll tell me after I've picked a product that I want to put in my cart. Products who bought this also bought that. That with LinkedIn, they want to know, do you know this person, that person, whatever. They're trying to suggest new people to add to my network. That they're making, it's describing things, but they're sort of predicting at the same time. Others that we do, and this is getting much more sophisticated now, my customers are really diverse. Like this class is really diverse. I don't know much about you. Until I get the survey, I probably don't know much about the class as a whole. And unfortunately, I'm not going to be able to pull out, oh no, I will. I am asking you whether or not you're studying online. So I'll be able to see what's different about online students versus students that study in a classroom. But even my online people are very diverse. So do I treat you as all being different, or maybe I can cluster you into students that are online because they're working and studying part-time, those that are not located in Halifax, they're located somewhere else and doing it at a distance, other types of things about their program. Maybe they're playing catch up, their program's out of sequence or something. Can I cluster my customers into a small number of market segments so that those different market segments, people are somewhat similar within the segment, but the segments are quite different from each other? It allows me to target my messaging in a more effective manner, to recognize I've got a diverse market, but not trying to talk to everybody individually because I can't. In a lot of cases, there are so much data we've got about customers that we're overwhelmed with the amount of data. We want to know what are the key customer characteristics we should focus on to be able to understand who you are. Is there a way of reducing our problem down and figuring out what's really important and what are distractions to us? And sometimes the distractions to focus on, our attention gets focused on them, and they're not important to our business. How do we figure that out? Sometimes we've got too much data. And can I make decisions with smaller amount of data? Which data? Lots of different things. So data mining applications tend to be split into the descriptive and the predictive. And then here we get some jargon. Descriptive ones, we're just trying to summarize patterns. So there are patterns we're trying to discover. We're just trying to summarize them. We're not trying to predict anything from them. That these descriptions aren't being supervised. What do you mean by that? Okay, I'll get to it. But this comes out of computing science, and for whatever reason, they call this unsupervised learning. Methods that just describe what happens. I find it very confusing. For a long time, I didn't understand what they were talking about. In predictive applications, we're trying to predict an outcome based on the information we have. Is the customer likely to renew their cell phone plan with us? We're going to try to build a formula, say, with several variables. We're going to try to predict yes or no. Are they going to renew? That building that formula, we're going to train the formula based upon the data that we've got. In that sense, we supervise the training. Okay? We're teaching it, we're training it, we're supervising it. That's called supervised learning. So descriptive, where they're not training it to predict something, is unsupervised. Okay? Why do we call it learning? Well, once we've completed it and built a model, we're going to try to set the computer up so that it can actually start teaching itself as it gets new data. As time goes on, new data becomes available. And the computer is going to revise its model, teach itself how to build a better model. It's learning. The machine is doing the learning. And so that's called machine learning. And you may have heard of that in the context of artificial intelligence. A lot of stories are coming out at the moment about machine learning and artificial intelligence. You may have heard of GPT. It's a chat GPT. Google it, look into it. Might be able to write the term paper for you. It goes and tries to create text based upon what you've asked it to do. It's getting closer and closer to being like a person creating stuff to you. I've posted a video called Machine Learning in 5 Levels of Difficulty. View it. It's only like 15 minutes long, but it's really, really, really good. Far better than I could ever do. But it'll give you an idea of the different levels of understanding of what this is. And it can get very complicated. But this video is structured for an audience such as you. And it's incredibly well done. I really enjoyed it. I learned from it, even though I've been studying this for a while now. So descriptive, give you some of the classic applications like you had in 1205, where you had classic optimization examples. We have some classic ones for descriptive and predictive modeling. And there are others as well. This is not meant to be an exhaustive list. So there's clustering. As I said before, trying to group cases together, customers in particular, so that the cluster of customers are very similar one to another, but the clusters are different from each other. So instead of thinking of 1 million different customers, I might think of 8 different clusters of customers, 8 different market segments. And the data formed those market segments. It wasn't me doing simple things like I used to do with student recruitment of the Halifax market, the Nova Scotia or Maritime market, of the Ontario market or the Chinese market. Those were very crude, just based on geography and nothing else about the individual. Use your data to find much more complex descriptions of your different market segments. Concurrence grouping, those are 2 things that are bought together. So that's what Amazon frequently does to you. And so if I order a printer, it'll suggest that I order printer toner cartridges at the same time, because usually people buy them together. That's nothing new. That grocery stores here, come the end of June when strawberries were in season, would have strawberries, fresh strawberries out there. And they would also have a display with little cakes to make strawberry shortcakes. And they would also have for artificial whipping cream to be able to put on top of your strawberry shortcake. They'd cluster things together. Similarity matching is often just cases where we're trying to find cases that look similar to one that we're looking at the moment, to give us insight, to find others that are similar to it. Previous experiences you've had that are similar to this one, that'll give you insight. Profiling. It's not clustering. It is taking an individual and then trying to describe them in terms of characteristics of that builds that profile of the serial killer or whatever. So it's like trying to define a group and then describe the group. Data reduction, talked about that. How can we get by with less data? Feature selection, what are the most important features? Because I've got too many. And now we've got sometimes not just hundreds, but millions of different things we could look at. I won't get into how do you get that type of thing. But for example, in my previous role, trying to advise students, work with students about different problems, I could look at their transcript, which was a lot of data at once. And the different courses they'd taken, the grades they got, the different profs they may have had, when they took it, it was really too much information. Often you'd sort of start by looking at their average. You needed to understand where the average came from too. So I like to look at the average first, gave me first thought, then I actually look back to the data that gave me the average. But in many instances, we made the decision to admit you to university based upon your high school average. We didn't look at your whole high school history. We reduced it to that just one thing. Causal analysis is trying to find relationships, really what causes things to happen. That causal analysis is not always easy to do. We may be able to build a model that predicts whether or not you're going to renew your cell phone plan, whether or not you're going to keep getting internet access from Eastlink, Bell, or something like that. But I don't know why. I can't explain how they work. It's actually a growing area of research. We were interviewing a person recently. One of her areas of interest is explainable artificial intelligence. After you build this complex model, how do you explain it to someone else? It's important. The predictive ones, and that's going to be the main focus of the course, is three things, really two of the big ones. There's value estimation, trying to predict a number. Like if I was trying to predict what your grade point average will be at graduation, what's it going to be in May? That predicting a number. Versus classification, it's whether or not you're going to come back to St. Mary's in September. That is a classification, yes or no. Or maybe I put you into a couple of groups. Yes in September, no, you never returned, and you took some time off. Maybe there are three choices. There may be more than two. We'll look at when you have two choices. Link prediction is more like suggesting, if you're on LinkedIn, you'll get suggestions of people to add to your network. Ones that they're trying to predict that would be good links for you. So we're going to look at classification and value estimation because they're the most frequently used ones. So anyway, getting back to this, why are we doing it? It's so that when you are faced with a new problem, you can figure out, well, where do you start? When you think back to last class with Target, they want to know which of our customers is pregnant. Well, that's a classification problem. You're pregnant or not pregnant? And so the next question would be, okay, it's a classification problem. How do we start one of those? What do we do? What do we need? So that gets us into this idea of a process. So problem solving in a math course generally is, how do you solve this calculus problem? How do you differentiate this function? How do you find the square root of, anyway, how do you find the area of this? Those are not problems that a robot could do on any of those types of things. That if you were trained in carpentry tools, how to use power saws, how to use a lathe, how to use a drill press, how to use, how do you hammer a nail, how to use a screwdriver, what are the different bits that are available? They may be simple things, they may be complex things. But that isn't the problem you solve. That's how to use a tool. And most math courses teach you how to use tools. A lot of accounting is how to use tools. Those aren't how to solve a problem. Or if there's a problem, it's a very structured problem where you're told, hit this nail here. Most of our problems are semi-structured or unstructured altogether. And in many cases, we don't know what the problem is. We have to go through a whole problem finding exercise and then define the problem. That my car won't start. Well, now we've got to diagnose what's wrong with your car. So we need to find the problem before we can fix the problem. That my competitors are doing better than I am. That's a problem. Now I need to find the solution. I need to find the cause of that type of thing. So there are a lot of different frameworks for problem solving. They're actually all pretty similar. And there's a specific problem solving frameworks for data mining. One of them we're going to use called CRISP. And it's similar to some others that are out there. And if you've been taught any problem solving in other courses, you'll likely find this doesn't look that different, and it shouldn't. So we start out with what we call business understanding, and I'll explain what that is. We move to data understanding, going from a business problem to a data problem. And then I'm going to need to prepare that data in some fashion. We're going to build models. Like you did in 1205, you built models. We're going to do some evaluation, and then we're going to try to implement our solution. In most math courses, most management science courses, they focus on modeling. We're going to be doing a lot on modeling, but we're also going to spend a lot of time on data understanding and data preparation. And we're going to also spend some time on evaluation and deployment, because you haven't solved it until someone uses your solution. So there's a lot more work to be done. So, Chris, what is it? It's a cross-industry standard process for data mining. The R, I presume, is because they didn't want to call it KISP. Anyway, it's circular. You'll notice in this model that there's a lot of back and forth, particularly between business understanding and data understanding, modeling and data preparation, evaluation going back to data understanding. I think there's more probably backward arrows. There's probably as many backward arrows or more than there are forward arrows. In my experience, I've seen backward arrows from every stage, and that is good. Going backwards is not meaning you made a mistake, something you got to get over. You have to backtrack in a lot of instances, because as you move through the problem, you learn more, you know more, and you may have to recognize that you didn't understand what you were doing previously, and you have to do it again. I've encountered countless managers, most managers probably, are terrified to admit they made a mistake, and they don't go backwards. So even though they know what they're doing is wrong, they will still go ahead and do it, because to not go forward, they think shows weakness. In my view, admitting mistakes is a measure of strength. Think about it differently that way. Anyway, that we've got 6 stages. The stages aren't independent. As you do one, it influences the next. And that look ahead, look backwards is really important. I tend to merge certain stages. The data understanding and data preparation, I tend to merge. And analysts may merge various stages, or evaluation we find we're doing at modeling as well as at a later stage in a different way. So what do we mean by these? Business understanding. Understanding what your objective is. And then what does success look like, and can you actually measure it? That understanding what your objective is actually very, very difficult to do, and is probably where most projects go off the rails right at the beginning, because they have not defined their objectives in a very sharp, precise fashion. And when they're finished, if they were to go back and say, oh, were we successful? Did we achieve? They have no baseline. They didn't collect data before they got started. So they don't know if they're better off than they were before or not. You'll get their opinion, but that doesn't really count because they're biased. They've got a stake in it. So you have to think about measurement at the very beginning and getting a baseline. That the focus very much is going to be on outcomes. So if you're at a meeting about doing something, achieving something, you're going to be talking about what you want to achieve. You'll have the naysayers at the meeting and say, oh, no, we can't do that. Or so-and-so is going to get in our way. They're talking about obstacles in completing the project. This is not what we're talking about here. We're talking about the destination. Where do we want to go? And yes, there will be obstacles in getting there. We'll deal with those. But where is it you're trying to go? You're trying to describe the destination, and trying to, when saying, can you measure it and what success look like? Do you know when you've arrived at that destination? We're looking at it in the context of data issues. And we need to have some appreciation by the different players, the different actors, about the role of data and whether or not they will act upon things when the data indicates things that they didn't believe in. So we saw through COVID that there were a lot of detractors to aspects of actions that were recommended with COVID because they didn't believe the data. They argued that it was wrong. You get that constantly. That so we need to have some data understanding and some maturity among the actors. Maybe you're going to be, that's the purpose of you understanding this, is because you're just going to be an actor and you need to understand the data. You're not going to be doing the analysis. The actors are important because there are those that make decisions and those that implement them. And they're different. Frontline workers implement them. And often they have knowledge, a lot of knowledge about what's going to happen, and the managers don't. And understand whether or not managers listen to their frontline staff or seek input from them. You need to understand all the players in that process. And so in moving towards data understanding, you're going to need to go and specify this as a very precise question that you may rephrase it like, you're trying to increase sales at Target. Okay, that's a big general objective, but let's drill down to this question about pregnant women. If I know who's pregnant, then I can do such and such. So you're seeing a relationship there, how you can change behavior. So that's where you're trying to get. And then you'd want to know, can the data tell me who's pregnant? That becomes a data mining type question. We need to translate that business objective into a set of questions that data mining can answer. So it was, if I knew which customers are pregnant and when a baby is due, then I can send the appropriate promotions to better engage them as customers. So can you tell me who's pregnant? Can you tell me when the baby is due? That those are data mining questions. Previous one is saying sort of where it's coming from, the root of it. So data understanding, we're starting to think about, well, what data do I have? And what data do I need to answer the question? How am I going to get it? And what does that data actually look like? Can I trust it? What is the quality of that data? Often the data has lots of flaws to it. It's not perfect. So Target said it had a lot of data about customers and they could buy more data. I'm not sure about specific customers or not, or how they could do that. With respect to pregnancy, though, that was really only data about women that signed up for the baby registry. Those that didn't sign up for the baby registry, they've got customer data, but they don't know if they were pregnant because they didn't sign up. So there are gaps in their data. That they know data about some customers, but not about others. They do know for those that are pregnant when the baby is due, and they have detailed purchase records. So that's really good. So they could construct a profile before and during pregnancy and see how that changes to be able to model customers that are pregnant and compare that to customers that might not be pregnant. There's a lot of data that they've got. They got every transaction. That could be thousands of pieces. How do you use those little pieces? How do you assemble them into something? You don't know what to do with it. So although we can pull a lot of it out of the database, we're going to need to squish it down, transform it in some fashion. Look at how many purchases they made per week of certain products. Do we need to know what size it was or what brand it was, or we may need to relabel stuff. There's a lot of sorting through that. And they need to clean it up because there's probably errors in the data, that outliers to it for a variety of different sorts of reasons. And so, and we will find as we look at data, there's stuff that's strange, doesn't belong there. So we need to organize that purchase transaction into a usable form. We need to group data, squish it down, summarize it, average it, that type of thing. Just like with your transcript, we squish it down and we say, how many credits have you completed? What's your grade point average? So we squish things down in certain ways. Modeling, well, with predictive models, we're trying to develop a formula. It's got an outcome and it's got inputs. So it's like a function. And that, so how do we do that? Or maybe it's a decision rule that maybe it's just a description. That could also be a model. That, so we're going to look in modeling in particular, then you really need to know about the different types of classical data mining applications, because each one may have certain models that go well with it. And we'll see ones that go with value estimation and classification. And there are many, 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 many different approaches that people use to do it. And we'll need to understand, how do you calibrate a model? You fine tune it, make new adjustments. And if you have different ways of doing it, which one do you pick? So we'll see that as we go on during the course. So in Target, in sort of the data preparation through modeling, they were able to identify 25 probably product groups, like body lotion, not the brand, not the package size, not whatever. And they use those 25 variables to come up with a prediction score that would say, if you scored 85%, there's an 85% chance that you're pregnant, maybe. And then if they predict you were pregnant, they probably use those variables again to predict, well, where are you in the pregnancy? So when is the baby due? So the classification model predicted whether or not you're pregnant. And then they used a value estimation model to predict when the due date would be, how long it's going to be. But the models aren't perfect. That each day, if you go to the Weather Channel, look at their forecasts, and they say there's a 30% chance of precipitation tomorrow, or there's an 80% chance. They're not saying it's guaranteed it's going to rain tomorrow or it's not going to rain. They're trying to give you an idea of the accuracy of their prediction, because it's either going to rain or it's not going to rain, or it's going to snow or not going to snow. All models make mistakes. And it's very, very difficult to make what I'd call accurate predictions in terms of ones that you would really, really, really trust. That they're not exact, that you're going to make mistakes. So how do you measure performance? And even if you're right 85% of the time, is that good enough? Maybe you need to be right 95% of the time to be successful. Depends upon the application. So we need a measure of performance, and then we also need a measure of success. And so success is in terms of meeting a performance threshold. So maybe its success is sales increased by 4%. Yeah, we're successful. So in the story, at least as it was told in the little video, or at least the New York Times magazine article, said, take a fictional customer. She's 23, lives in Atlanta. In March, she bought lotion, purse, diaper bag, blah, 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 blah. It maybe they feed that into the model. They say there's an 87% chance she's pregnant. And if she's pregnant, delivery date sometime in late August. Well, how accurate is the late August? Could it be late July? Could it be October? Should we really trust the 87%? How accurate is that? She isn't 87% pregnant. She is or she isn't. In deployment, we have to go back and ask ourselves, is the model doing what we wanted it to do? That it should, if you define your steps in the process properly. Does the user understand the model? And will the user accept the output from it? So I saw a recent example of a machine learning model to predict whether or not a customer was going to default on a loan. So whether or not we should give them a loan or not. And loan officers were given what the robot, the AI, told them was likely to be the case. Are they a good customer or a bad customer? And it was interesting to see that some loan officers agreed and other ones would disagree. Did they use the output or not? And it was interesting to see when would they use it, when they wouldn't. So you need to understand the frontline workers. They don't necessarily, if they're going to be held accountable for their decisions, are they going to trust the computer's recommendation or not? Who's going to maintain the model? Because over time, you're going to get more data and our environment keeps changing. As we've been seeing in the last 4 years, every year has been very different. Every month's been very different. And not just because of COVID, the war in Ukraine, all kinds of other sorts of things have very disrupted. It's really hard to predict what's going to happen next month. So as you get new data, it should help you make better predictions. So someone is going to have to maintain and update that model. Are there ethical issues with respect to implementation? We saw in Target that they were creeping out customers that they knew when a teenager was pregnant before the family did. Is that dangerous? There are a huge number of ethical issues. And as machine learning models get better, there are more and more ethical issues coming out constantly. And you need to think about them. You may get in hot water because of the model you're using. And that's sort of because of unintended consequences. With Target, it was creeping out customers. They had to rethink how they use the information to be able to influence customers. And then there's sometimes we get through the whole thing and then realize we misspecified our question at the start. We've learned an awful lot, but we should probably do it all over again. And you've got to be strong enough to go back and say, we're not there yet. We need to do it again and go back and repeat it all over again. And with that cycle that you saw in CRISP, it does that. So with Target, there were a lot of different things on the deployment that they understood how to use that data. Some of it they did know, some of it they had some problems with. The best of I can understand, they use fairly traditional models, but they had additional models for targeting how to use the data. What's the best way to influence individual customers? That they were really happy because they identified what they thought were tens of thousands of good quality prospects. So they weren't all pregnant, but they were ones they didn't know about. Even if half of them were pregnant, half of them weren't. They identified a huge number of pregnant customers that they had no idea were pregnant before, so they could target their ads much, much better. They uncovered a bunch of ethical issues. The success of the model, though, sales did increase. Management was really thrilled with the results. That gave credibility to the data analysis group, and so they came back with new questions and raised expectations of what they were going to do for them. So trying to bring this to a close, data mining is a process. It's not a specific tool. And it's understanding the steps you go through. Don't worry about the math. The math is not important. It's important for some, but it may not be for you. But there are a whole bunch of steps. And that understanding and identifying that business issue is probably the biggest problem that we get. Our data is usually messy. It's usually dirty. That becomes a problem, something you need to be familiar with. Like with optimization problems that you may have done in 1205, having mental pictures of different types of problems, I find helps me in identifying, how am I going to deal with different ones? As you'll see through the course, I'm a visual person. I need to have pictures in my head to be able to see what I'm doing. And understand that you're never finished. saying you solve the problem, you have not solved the problem until the business says you're successful. So don't throw it over the wall and expect someone else to implement and say, oh, I've done my job. You're not unless they actually act upon your recommendations. This is something for the in-person class. I'm going to have to ask you to answer it by email. Send me some sort of feedback. I'd appreciate that. Tell me whether or not you've actually looked at the video. I've heard it said time and time again, we forget 80% of what we learn in a day. Sometimes I think it's more than 80%. Stuff goes into my head and it dribbles right back out of my head. Within minutes. It's incredible. After you leave a class, think back, how much do you remember from that class? 5 minutes after you left the room. You forget huge amounts. It's incredible. It used to be I was frequently having to attend workshops, seminars, that type of thing. I still do when I can. And many people would say these workshops, seminars were a waste of time. I already knew that. Knew that stuff, whatever. I attend them looking for something that is different, something that's new that I didn't know before. And in particular, a new idea that can help me in the future. It may not help me tomorrow, but I think, hey, that's interesting. I got to remember that. And if I walk out thinking I learned one thing, just one, even with a full day workshop, if I walk away from it and I learned one thing, it was a success. Too often I found I didn't learn anything. Anyway, I want to know, what was your main takeaway from today? Is there anything that you saw today that you think is useful to you and you like to tell me that you remembered and you think, I should think about that in the future? I'd like to know that. It helps me in planning how I teach. So what's next? So we're going to go through that cycle, but business understanding is very much context specific, depends upon the problem. So I really can't dwell on it. I'm going to jump right to data understanding. I'll address it in the context of a potential business problem that was posed. But we're going to start getting into the data side of things. And then we're going to start getting into what did data look like? Where do we get it? And what problems should we be aware of? So to give you an idea of going through the cycle, there's a link here to an article that it was from a blog about the name Hillary and why an individual thought it was the most poisoned name in US history. And it was written by a data scientist, but it's easy to read. But it does give you a sense of her journey from posing the question about why she hated her name Hillary and thinking it was poisoned, to defining that as a data problem. Where could she get the data? How could she analyze the data? And then sort of in the analysis, it was also how would she communicate that to others when she wanted to tell them that this was the most poisoned name in history. Anyway, and if you follow US politics and the Clintons, I know Hillary Clinton is now history, but much of the blog had to do with Hillary Clinton. Anyway, that's it for today. Thanks for your patience. And I hope you come back to see me again for day 3. Take care.